Xavier plans to make and sell his own all-natural shampoo. And here the graph below gives us the marginal cost, MC of Q in dollars per liter of Q liters of shampoo. So there are already a few things to pay attention to. For example, they give us the units for MC. So the cost is in dollars. And how quickly is the cost changing? Well, it's per liters of shampoo. So I guess it's also good to point out, in case you forgot, that the marginal part of marginal cost is really just a fancy word for derivative. So MC of Q is really just C prime of Q. So another way of thinking about it is that it's really the rate of change of cost. I guess to be more precise, it's the instantaneous rate of change of cost, but you know what I mean here. And in order to start making shampoo, Xavier must first spend $25 on supplies, but he has no other fixed cost. So I guess it's also good to point out that this $25 is really C at 0. So remember, when I write, say, C of Q, this is the cost for first Q quantities. So if Q is 5, for example, would be the cost it takes to make 5 shampoo. So C of 0 here, this $25, which Xavier has to spend on supplies, is called the fixed cost. So this is the cost that you're gonna start out with, no matter what, at the very start. So given the setup, we are given here the graph of marginal cost, or the derivative of cost, right here. What do we know? Well, now we get some information on revenue. So remember, revenue is the opposite of cost. If the cost is the money that you're spending, then how much money you're making is, of course, given by the revenue function, which is R of Q. And what information do we have on the revenue? Well, Xavier can sell up to 50 liters of shampoo for $10 per liter. And after that, any additional shampoo, he's going to sell for $4 per liter at a local salon. So what is the problem that we actually have to do? Well, for part A, on the axis above, carefully sketch the graph of the marginal revenue. So again, marginal revenue refers to R prime of Q, but it's usually written MR of Q, in dollars per liter of Q liters of shampoo. Well, the thing to realize is that from 0 shampoos to 50 shampoos, you're selling them at the rate. You're selling them at the rate of $10 per liter. So the marginal revenue, since that's giving you the rate of change of revenue, so maybe that's worth writing down. This is rate of change of revenue, since it's the derivative of revenue. So from 0 to 50, we know it's going to be 10. So we know we're always 10 here for the revenue from 0 to 50. And once you hit 50, now the rate of change of revenue now is only $4 per liter. So now you're going down to 4. So you're always 4 after that when it comes to the rate of change of revenue. So this is what MR of Q is going to look like. And just to reiterate, the initial curve is MC of Q, marginal cost versus marginal revenue. Now I guess one technicality is exactly at 50 what's happening. Well, at 50, from the left, your slope is always 10, whereas like from the right, your slope is always 4. So you have some sort of differentiability problem. So I guess if you want to be really precise, you want to make a hole here. It's an open hole because you're not differentiable exactly at 50. The slope from the left is 10, slope from the right is 4. Moving on to the next part, let's see at what value of Q in the interval is cost. So this is a very different question. Is cost maximized? And here the nice thing to remember is this version of fundamental theorem of calculus, which says when I try integrating from A to B, the rate of change of some quantity here, then we get the change in that quantity from A to B. This is really a fundamental theorem in disguise, because when I take a definite integral from A to B, I get the change in the antiderivative of this from A to B. Antiderivative of rate of change, well, that's just going to be the quantity itself, and we get the change in the quantity from A to B here. So for example, when I try taking integral from A to B of marginal cost, so MC of Q dQ, what do we get? Well, MC is the rate of change of cost. So when we integrate from A to B, we'll get the change in cost, or how much money we're spending really, from A to B. And similarly, when I integrate marginal revenue, you're gonna get the amount of revenue we get from A to B. And all that is to say is that if we look at this graph of marginal cost, and we take the area we take the area, say from 0 to say like 35 here. So when I look at the area underneath here, this area, which is the integral here, is the amount of money we're spending, the cost from 0 to 35. So if we want to maximize the cost, so you want to just maximize this area from 0 to q. So for what value of q can we maximize the area? Well, you do it by going all the way to 80, right? When we go all the way to 80, and realize here that all of this area is really treated with a positive sign because everything is above the x-axis. So we don't have to worry about putting a negative sign after we calculate the area. So when we go from 0 to 80, that's certainly when the entire change in cost is maximized. So the answer to part C is simply 80. And I guess another common sense way of thinking about this is as we're making more quantity, surely the total amount of money you're spending increases. So if you want to maximize the cost, then you want to make as many quantities as you can, which in that case is 80. So this should hopefully make common sense. Now let's go to part D. At which values of Q in the interval is profit increasing? And that's a very different question. So what is profit? So the profit function, which is written pi of q. So this is the profit when you're selling q quantities. And what should this be? Well, it should be the amount of money we earned, which is the revenue, minus the cost that we're spending. So the profit is just revenue minus the cost. And we are being asked, at what values of q is the profit going up? Well, when is profit going to go up? Well, let's think about this. Well, pi increasing exactly corresponds to the derivative of pi being positive, right? And when is the rate of change of pi positive? Well, rate of change of pi is going to be rate of change of r, the revenue, minus rate of change of the cost, right? When I just differentiate both sides. So the pi is going to be increasing precisely when the marginal revenue is larger than marginal cost. So the entire question is really just asking, when is the rate of change at which the revenue is flowing in larger than the rate of change of cost? So we're trying to figure out where is MR of Q larger than MC of Q, and we see that that's exactly happening from here to here, and I guess it's also happening from here to here. So what is that? Well, that starts at Q equals to 20, and then it ends at Q equals to 70. So we want to say this is happening exactly from 20 to 70. Now moving on to part E, how many liters of shampoo should Javier make in order to maximize his profit? So let's go up and reason this out carefully. So once again, the profit is revenue minus the cost. So if you want to see how much profit is changing, so how much pi is changing, it suffices to look at how much R is changing, and you subtract it by how much the cost is changing. And a fancy way of doing the same thing is by looking at the area in between this marginal cost and marginal revenue. So for example, we can look at the area here, or we can look at the area from here to here. So this is in between the revenue and cost. So this is another area we can look at, and so on. So why do we look at such an area in between MC and MR? Well, think of it like this. If I look at the area under MC, so if I look at the area under the marginal cost from here to here, so this is this entire area, including this top part, that's giving you by the fundamental theorem the change in cost. That's giving you how much the cost is changing in this area. And if I look at the area underneath the revenue function, so if I just look at the area underneath the revenue function, so just this rectangular area in this case, that's giving you how much revenue we're getting from 0 to 20 in this case. So if you want to figure out how much the profit is changing, you want to look at some sort of difference between the area. So that's why it makes sense to look at this area in between marginal revenue and marginal cost. But we have to be a little careful. These areas come with sign. For example, this area, is the profit increasing here or decreasing here? Well, here the marginal cost is higher than marginal revenue. So here, this area should really, after you compute the area, you should really think of it with a negative sign. In the sense that when Q changes from 0 to 20, then the profit is going down. It's going down by this area. So that's why you should think of it with a negative sign. Whereas, for example, the area here, you should think of it with a positive sign. Because here marginal revenue is larger than marginal cost. So here the profit is increasing. So when you go from 20 quantities to 50 quantities, the profit that you're making is going up. It's going up by this area exactly. And then we can repeat the same sort of thing. From 50 to 70, we see that this area is also positive. So you're going up by this much area. Whereas from 70 to 80, we see that the situation reverses. You're going down. The profit goes down by this area. So that's exactly what's happening here. As you're moving to the right from 0 to 80, you're initially sweeping out this area, so you're getting more and more negative profit, and then you start sweeping out this area, and then here you're getting positive profit added to it by the amount of area, and then you keep on getting positive, and then you get some negative profit here. So now the question is, what quantity do we want? What Q do we want for us to maximize the signed area? So I'm saying the signed area, I guess, in the sense that area is always positive, but sometimes you treat it with negative sign, or sometimes you treat it with positive sign. So where should we stop? Well, clearly, the area here more than compensates for the negative area here. So the place to stop is clearly at 70. So at this 70, your profit is maximized. So the answer we get, part E, is 70. Now let's look at the last part. Write an expression involving integrals that represent the company's profit when Q is 45. You should realize a relevant integral is integral from 0 to 45 of MR of Q minus MC of Q dQ. Why is this? Because integrating MR of Q gets you the change in revenue from 0 to 45. Integrating MC of Q gets us the change in cost from 0 to 45. So when I integrate from 0 to 45 of their difference, this gets us the change in profit from 0 to 45. Make sure you're doing marginal revenue minus marginal cost. But this isn't quite right because we got the change in profit from 0 to 45, but that's not quite the company's profit when Q is 45, because how much profit are we starting with at 0? Well, when quantity is 0, remember, I guess we're not making any revenue according to the problem, but at initial quantity, we gotta start by spending $25 on supplies. So we actually have a fixed cost of $25 that you're starting at. So you're actually starting in the negative. So we want to start at negative 25. And after that, we're making this much more money, or maybe this less money. So your total profit by the time we get to quantity of 45 should be negative 25 plus this integral.